In this video I talk about an application of a comparator being used to generate a square wave from a sinusoid. So here's our circuit. We're calling this voltage that's connected to the inverting input the reference voltage. Often with comparators, one input will be a fixed amount of voltage where the other input will vary, and the fixed amount of voltage input is often referred to as the reference voltage. So this is just Vn in the previous video, and then Vn is the voltage that's varying in time, and that was Vp in the previous video. And then here's our power source values again, plus V and minus V, and here we have our output. So just remember that when the voltage on the non-inverting input is greater than the voltage on the inverting input, you'll get the plus power source value for Vout. And when you have the opposite case where the voltage on the inverting input is greater than the voltage on the non-inverting input, then Vout will be the minus power source value minus V. So we could just quickly write that down here at the side to remind us that if Vn is greater than V reference, Vout is plus V. And then if we have the other case, all right, so you see here's our input sinusoid varying sinusoidally in time, and anytime that this sinusoid is on the positive peak, well, that means that the voltage on the non-inverting input is going to be greater than ground, which again, as you know from circuit theory in this class, we've talked about this plenty of times. Ground is where we use as a reference of 0 volts. So during these time periods where we have a positive half cycle, Vout is just going to be at the plus V amount, whatever that may be. See, so all the positive peaks will have a constant plus V. And then during the negative half cycles, well, that's where we have the other case where since the inverting input is greater than the non-inverting input, Vout will be the minus source value. So during all these negative half cycles, that's when we have minus V. So you see the output is just going to oscillate between the two power source values, and at the output we'll have a square wave that varies between plus V and minus V. So again, those of you that have taken a lab, or if you're presently taking the lab that goes with this course, you see this in the lab when you use a function generator. Function generators are pieces of equipment that you can get various waveforms such as sinusoid, square waves, triangular waves, and so on. And the circuitry inside a function generator is often just like this, where when you select that function generator to output a square wave, well, you're seeing the output of a comparator circuit. Likewise, we talked about an integrator a few videos ago, and integrators are used in function generators to generate triangular waves from square waves. You know, if we took this square wave and then put it at the input of an integrator, well, we would get a triangular sawtooth wave at the output. So when you select a triangular wave, you know, a sawtooth type of triangular wave from a function generator, well, at the output of the function generator, that's what you're seeing. You're seeing the output of an integrator. Now, usually, or a lot of times I should say, the plus V and the minus V will have the same magnitude. So, you know, if this is plus 12 volts, this will be minus 12 volts, and you'd have a square wave varying between plus 12 and minus 12. In some comparators, you know, remember, they come in integrated form, and some comparator ICs require that these magnitudes of these power sources not be equal to 0. They don't necessarily have to be equal, but some op-amp ICs, you cannot make the minus power source 0. Like, you couldn't just ground the pin of the IC that this corresponds to. But there are special type of op-amp ICs, in fact they're called comparator ICs, where you can go ahead and ground the minus V pin, and therefore you can get a square wave that varies between some plus voltage amount, say like 5 volts, and 0. Okay, but I just caution that not all op-amp ICs can you ground the minus V pin. You'd have to look specifically at the data sheet for that IC to see if you can do it. But if it's called a comparator IC, then it should be no problem grounding minus V if you wanted to do that.